Hello guys, welcome back. So here we have another question on network theory from KTE 2016. If an ideal transformer has an inductive load element in port 2 as shown in the figure below, the equivalent inductance at port 1 is dash. So this is the network, and here they have a transformer with turns ratio of n is to 1, and they have an inductor L connected as a load here. So looking from port 1, they are asking what is the equivalent inductor. So at first glance, if we try to see, this is having n is to 1 ratio. So you might think L will become NL here. But that is not the case. We'll see what happens. Okay. So let me take this. So for a transformer, what is the thing going to be? So if this is V1, if it is I1, if this is V2 and this is I2. So the direction of the positive current itself will be how these uh, windings are wound with each other. So for now I'm just taking this, anyway it doesn't matter. So for n is to 1 turns ratio, V1 by V2 is equal to, at least in this it is equal to n, right? So if V1 is n here, V2 will be 1. And the important thing is power is gonna be same, right? Why is this? Because this is a passive element. Transformer only transforms the energy, it doesn't create any energy. So power is gonna be same, which means that V1 I1 is equal to V2 I2. So I1 by I2 is equal to V2 by V1. So I1 by I2 is equal to 1 by n. Okay, so these are the two important things we need to know. So now how you will find the equivalent inductance here? So we can go to either the Fourier domain or the S domain. So in the Fourier domain or S domain, your L becomes SL. And to find the equivalent impedance looking in, since this is only an inductor, we can connect some voltage source, let's say V, and we'll find the current I. So V by I will give me the equivalent inductance, right? Okay. So once I connect V here, what does V1 become? V1 becomes V. Then from 1, what will be V2? So this is V2. So if you go back, V2 is equal to V1 by N. So V2 is V by N, right? So now V2 is V by N. What is I2? I2 is nothing but V2 by SL, right? The voltage by the impedance. So this is nothing but V by N into SL. So if you see, I2 is effectively like the impedance is NL. But we need to again refer it back to the input, which is I1. So what is I1? I1 you can get it from 2. So I1 is equal to I2 by N. So I1 is equal to V by S into N square L. Okay. Now I1 is nothing but I. So I is equal to I1 equal to V by S into N square L. So what is the Z equivalent? Z equivalent is nothing but V by I. So it is V by S into N square L. So Z equivalent is equal to N square L. S into N square L. So your L equivalent is nothing but N square L, right? So the equivalent inductance is actually N square L and not NL here, because the voltage is also getting divided by N here, and once you get the current here, when you refer it back, that is also getting divided by N. So effectively the equivalent impedance is gonna be N square times the whatever the original inductor was. Okay.